7 tips for successful CDC design. Let's understand using this video. So the first important thing is to use multi-flop synchronizers. When you're transferring a CDC signal from one domain, from sending domain to the receiving domain, if you just use one flop, there can be metastability on that flop. So you always have more than one flop, which is also known as synchronizer, to basically avoid that metastability. How many flops you need depends on what you want your MTBF to be for the design, but the first tip is very, very important. Use multi-flop synchronizer. Second tip, very, very important tip. If you're using a synchronizer, don't tap a signal from the early synchronizer stages. So here there is a synchronizer. You're sending a CDC signal from sending domain to the receiving domain, and this is the first flop of the synchronizer. This is the second flop of the synchronizer. Don't tap a signal in between the synchronization stages. That can make your MTBF go really bad and may possibly cause cases where this metastability can actually propagate in the design. Third tip, avoid combination logic feeding to the synchronizer. If you have a combination logic and feeding it to the synchronizer, it can cause glitches in the design. And how to avoid that is you add a flop here first, tap basically that combination logic output to first flop in the same domain and then feed it to the synchronizer. Tip number 4, when there are synchronizers in the design, multiple synchronizers in the design, like in this case synchronizer 1, synchronizer 2, synchronizer 3, when they converge later in the design, there'll be what is known as correlation loss. Account for that correlation loss when you're designing. If there is no way to avoid this combinational combining of the signals, encode the signals in binary, convert them into gray encoding, convert from binary to gray, and after synchronization convert from gray to binary, to account for correlation loss, so that you understand there is going to be correlation loss and you're accounting in your design to take care of that. Tip number 5, have a feedback, have an acknowledgement signal. If you don't have feedback, let's say you're transferring a pulse from here, from the transmitting domain to the receiving domain, the transmitter does not know when to send a new pulse again. Unless you're really relying on particular frequencies of the design, if the design frequencies change, this circuit will stop working. So always have a feedback or acknowledgement when designing these synchronization protocols. Tip number 6, avoid combining the signals after synchronization. If you're sending two signals, signal A and signal B, to synchronizers, and then combining it after that, avoid that. As we saw, that you can have correlation loss and this may not behave as intended. So combine the signals before in the transmitting domain itself, feed it to a flop because you don't want combinational logic feeding a synchronizer, and then transmit and just use one synchronizer. So avoid combining the signals after synchronization. And the 7th tip and the last tip, which a lot of people forget about, is be aware of the metastability effect. When a signal is going through synchronizer, the pulse of the signal can be shortened. How it can happen is, for example, the signal changes very close to clock edge. It is not captured in the first clock cycle. Rather, it is captured in the second clock cycle. So the pulse, which would have been longer because it was captured later, gets shortened. And pulses can be stretched also. For example, this signal going from 1 to 0 happens very close to clock edge. It is not captured in the first cycle itself. It's captured actually in the next cycle. So pulse got elongated. So plus pulses can be stretched also. So because of metastability, pulses can be shortened, pulses can be stretched. Be aware of these metastability effect. If you want to get in further details of these, we do have full courses on CDC. Check out our website www.vlsideepdive.com. If you like the video, please like and subscribe. Thank you for watching this video.